Pleasure to be here with all the participants and giving this presentation. So start off with just going over a brief overview of our company and how we got started. Yadah is on a mission on simplifying energy storage. Uh, we call ourselves Solar plus Smarter Storage. And we believe that for energy storage to really reach its full potential, we need to simplify it to a degree to become more deployable. And that's been the core driver of what our company has formed and what we've been developing over the last 2 years. So I like to start presentations with an overall trend, and that is we still have a long ways to go. Renewables have climbed quite a bit in these last few years, this last decade. But as you can see on the chart to the left, majority of our energy consumption globally is still kind of enjoyed by oil, gas, and coal, although renewables have been climbing steadily, right? And the good news on the right graph is that both oil and coal have been declining over the last 10 years. And natural gas, renewables, and hydro have kind of been, gas and hydro have been climbing, but particularly renewables, which defines wind, solar, and some alternative renewables, have had a nice steep rise over the last 10-year trajectory. A lot of this is due to the price drop in commoditization of the solar PV module of standard silicon PV cells. Back in '77, the average price was around $76 a watt, which was quite expensive. A typical 300-watt panel would cost several thousands of dollars. And today, with global manufacturing and its scale, the average price at wholesale for an installer is around 30 to 40 cents. And this means that the generation source of solar energy has come down quite a ways, right? It has essentially grown this industry to really become price competitive against fossil fuel-based generation, not only in large-scale deployments, but now also in regional deployments and residential rooftops to commercial buildings. However, the growth in the commercial solar and storage has kind of been lagging. Those of us that are in the industry, there's a strong growth in residential markets, specifically here in the US. There's a huge growth that's happening globally on utility scale projects. And the commercial solar sector is growing, but it's just not growing fast enough. We have some data that suggests that 97% of commercial rooftops still don't have solar on them. And as a company, we believe that storage changes this paradigm, in which solar is seen in a different lens, right? Traditionally, from a utilities perspective, the more and more solar that's deployed, the less and less kilowatt hours that are sold, and more problems it can cause over time from backfeed and having to upgrade different transmission lines. But storage kind of changes this both for the end user, the owner of the system, and also the utility. What storage enables is the ability now for solar to also affect demand charge at a controlled setting, knowing that you can discharge power at a given time to reduce the bulk of power pool for a specific building. It allows for a higher kilowatt hour offset, so rather than just dumping the power intermittently into the grid, you can actually control and choose to offset higher kilowatt hours. This is known as load shifting. And most importantly, it enables resiliency, which is the ability for a building to have backup power. And I'll talk a little bit more about why this is so important to this industry in a later slide. It also now brings the utility to the table, right? They can choose to not be a part of it, but if they choose to be a part of these systems, they now have a lot more benefit than, per se, the end user or the building owner does. They can utilize the storage on a building to do energy trading in the live markets as prices fluctuate. They can use it for different demand response programs. They can place systems strategically throughout a city to minimize distribution deferral, or to maximize distribution deferral. And they can do peak power offsets. And a lot of times in a lot of markets, the peak power is coming from fossil fuel-based coal and natural gas generators. And lastly, they can actually monetize resiliency services. And as a model, we believe that commercial rooftops can add tremendous value and can in some markets be upwards of $3 per square foot of revenue potential that is currently untapped. So if you look at this marketplace, the current trends in energy storage are to place them in large, centralized enclosures, right? The leading form factor is a shipping container, and leading companies are focused on how many power electronics and battery cells they can fit in standard shipping containers. Some companies have built their own custom enclosures, and they still require some level of site-specific complexities, right? They might be a little more appeasing to the eye, the aesthetics, than a shipping container. And then the other alternative is, of course, to occupy interior space of a building. And those of us that work in the commercial building space, we know that every square footage has a value to it. So all of this means that each system today is looked at as a highly complex and site-specific installation. There are a lot of regulatory hurdles, such as fire safety and trenching and all kinds of permitting requirements that are now required. There's a very high, steep solar installer learning curve. These systems are quite complex. So there's only a handful of companies today that can actually adequately bid and install these types of systems. And this all leads to a high operating and maintenance costs for these systems. And we believe that the soft costs and complexities lead to slower market adoption in this technology. So at Yadah, we challenge ourselves to go further, and we designed a system of energy storage that can be distributed directly behind the solar module itself. And aside from the benefits of simplicity, what this enables is, by default, if there's room for solar PV on a rooftop, you now by default have room for energy storage. What Yatta Solution does, it's the first panel level energy storage that has a thermally protected battery system that can operate in both extremely hot climates and extremely cold climates, while protecting the battery to give it its original protected cycle life that the chemistries offer. And we do this without having any HVAC mechanisms built into the batteries. We cool the batteries completely passively. And this also mitigates fire suppression systems, because we now have a 1 kilowatt hour incremental battery that's in its own fireproof enclosure, rather than having one large bank of batteries in one specific location, which can be quite dangerous, specifically with some other types of chemistries. The other enabler is that with this form factor, we can now use the existing solar balance of systems, BOS, which means that we can actually pair on to the existing racking, use the existing wiring infrastructure, and even use the existing inverter systems that are out there on the market. And all of this leads to the highest industry efficiency with this architecture, because we are DC to DC at the same point, and we convert the energy storage to AC as it's needed at one single time with a shared inverter as the PV. This also enables a system that can easily retrofit and scale up or down. It leads to very low O&M costs, both from the implementation side and also to the management of the system. And our goal at Yadah is creating a battery that can equal the life of the PV module itself. And we believe that this is a revolution for the solar battery storage space, and it will lead to the lowest overall installed cost for systems of a certain size in our key market. And from a solar installer standpoint, they now can have a product that they can design energy storage for projects the same way they currently do PV. It doesn't take up any ground space. It's a very easy add-on for solar installers who have perfected the art of designing these systems for large commercial buildings. The weight of our battery is designed to offset the weight of a concrete ballast block. So now, instead of putting pieces of concrete on the roof to add weight, you now are using an active weight system. And all of these allow for the lowest installation cost of any energy storage system out there on the market, and enables remote design, which is key to this market, because being able to have a low customer acquisition cost by being able to design a system in the initial phase of selling it is very important, minimizing the amount of engineering work that's required. And also from a system standpoint, this leads to no single point of failure. So from an energy storage and resiliency standpoint, there's no single point of failure of your battery system going out. And we believe that this is essentially the safest distribution of implementing energy storage technologies onto commercial buildings. And just to kind of give it a comparison, we've done a market study of a current installation that happened. This is the Shed Aquarium in downtown Chicago, and just kind of highlights the value add that our solution can bring to the market. In this scenario, energy storage was deployed in 2 shipping containers, one for batteries and one for all the power electronics and inverter system, and where the batteries could be placed and where the interconnection of the building happened to be on 2 different sides of the building. And so there was a huge cost, close to $700,000, of just trenching the power from one side of the building to the other side. And on top of that, giving up 6 parking spots in downtown Chicago. By comparison, our product could have been installed for the same amount of kilowatt hours of energy storage at close to a 78% cost reduction. This is a specific case of where our technology of being able to deploy energy storage co-deployed with the solar modules can drastically reduce all of the soft costs and design costs that go into these projects. And people's main question, of course, is how is this possible, right? Our core team at Yadah has been developing this technology, and the core of what we do is we passively regulate the battery system using a proprietary method that allows us to keep the batteries in a protected zone. So batteries generally operate between 10 to 30 degrees Celsius, and 36 degrees Celsius is roughly 98 Fahrenheit. And we're able to do this by buffering the heat gains that the batteries experience during the daytime and using the delta between the day and the nighttime to passively regulate the battery systems. And as such, with our battery partners, we can actually give close to the STC standard test condition life cycle that a battery would experience, but now in an outdoor setting that can work in various climates. And what our company is also developing is now the SolarLEAF intelligence, and that's the software side of this technology, whereas we can optimize systems and build them to any size and aggregate them to a centralized inverter. So the end user, the customer, whereas it's a utility or a solar developer or a building owner management system, sees an aggregate potential of energy rather than each individual battery system that's on the rooftop. And we're working with certain utility partners now to build out utility controls. How can this system be monetized beyond just the customer side of the revenue stream of energy storage as well? There are others that are attempting this form factor, of course. At Yadah, we believe that the core of this technology and the validity of this form factor is the thermal regulation. You have to be able to prove that you can develop a battery system that doesn't degrade with high temperatures or extremely cold temperatures. And we've also pioneered an architecture that allows us to scale this beyond just a residential scale or behind microinverters. Our strings can work from anywhere down to 2 units upwards to 1,000 units and even upwards to utility scale type of deployments. And within the solar industry, our work has been noticed. Solar Power World picked Yatta's SolarLEAF as one of the top 2018 product innovations. And firms like the Solar Energy Power Alliance has named Yatta's solution as a potential game changer, of course. And this speaks to kind of the other markets where we can tap into beyond the commercial rooftop sector, which we have huge advantages against legacy, large energy storage, stationary energy storage solutions. And we believe that market map to be in various markets where it's the size of how many units we can deploy that are aggregated into the system. And so we're also talking with some wireless and 5G players on how to power certain devices more effortlessly than trying to tie them into the grid. There's, of course, the play into how this technology can deploy microgrids for disaster relief, powering smart city security devices and Internet of Things. And then, of course, in the bottom, you see the larger potential markets of the C&I solar space, microgrids globally, solar as a service, and then eventually the residential market as well. And just by comparison, in the microgrids, if you look to the left, you see what a standard legacy system looks like in a lot of these markets. And it's made up of close to 20 different components. And what's happened in the industry is the biggest cost factor in these systems is no longer the equipment. It's now the design and actual installation of these equipment. And a lot of companies are moving to kind of create a form factor of one unit that houses batteries and power electronics. But then that's difficult to scale incrementally to the size of system that you need. To the right, you have the SolarLEAF solution that now essentially integrates these technologies into one product. and brings down the balance of system components down to three core units: the solar PV, the solar battery, of course, the SolarLEAF, and then a inverter that can be both off-grid and grid connected with backup power. And we believe that this is pretty instrumental in emerging markets where the solar as a service model is taking off, because as people's energy access is brought to them, their demand for energy will increase. And if you can create a system that not only is viewed as infrastructure, has beyond a 10 to 12-year lifespan, but also can incrementally be expanded, it can be of high value to these players in these markets that are bringing power to remote communities. And of course, at Yadah, we are focused on our global social impact. Aside from bringing affordable, reliable solar plus storage, core to our model in our company is to develop a battery that has long life and is recyclable at the end of its life as well. And of course, the more and more deployment of energy storage that we have onto the grid system, we reduce our dependency on fossil fuel-based electricity, which reduces tons of CO2 emissions every year. And lastly, of course, the title of this talk was, how does this technology play into the utility sector? And we view that solar and storage in general is a nice meeting point from both the industry and utility, and that the value of energy storage is kind of yet to be realized mainstream in the market. But it can really only be monetized, it's best monetized when it's viewed in the lens of both the advantages that it brings to a utility company, traditional utility company, and both an end user. And as you can see on this chart here that was kind of pioneered by the Rocky Mountain Institute, placing energy storage behind the meter, which means usually behind at a building site, allows it to actually tie into all the services, all the ancillary services that energy storage can bring to a market. And as such, we believe that energy storage, in a sense, validates the continued growth of rooftop solar. Some have made the argument that with large-scale utility solar prices dropping to the point they are, why does it make sense to try to deploy solar panels on individual homes and businesses? Of course, we think the answer to that is energy storage, and the fact that with it, you now can add resiliency to buildings, which seems to be very important in various markets, and open to and important to the overall growth of this industry. Our team is made up of a core group of wonderful engineers and enthusiasts that have both had a great many years of experience in the solar industry, but now also many years of experience developing other technologies that were designed to work in the field behind solar panels for a long period of time. And we're excited for what's to come ahead and scaling this technology to various markets as we work with our partners. And Yaddah's gotten to the point we have, of course, with the support of various grants and utilities. And most recently, we were awarded the NREL Wells Fargo IN2 program, which allows us to do third-party validation and commercialization work with NREL, which is the National Renewable Energy Laboratory. And with that point, I'll now turn it over to any questions you might have. Hi, John, are you there?
Hi, we're here. It looks like there's someone who's typing a question into the chat window. We'll see what they have to say. Just one.
Okay, wonderful. I'll pull up the chat window. Yeah, while this person's typing their question, I'll just talk a little bit about kind of how we got here and the motivation behind this product. So I got an early start into the solar industry back in 2009 when the price of PV was still quite expensive. And I took a break and traveled internationally with my wife and went to a lot of different remote communities that were still powering themselves with diesel generators. And this all started with an effort of how to design an effective system to send out to these people versus having to send someone that was technically minded to install it every time. And the natural progression of that was to kind of focus on developing panel level energy storage to simplify the whole architecture of these systems. Okay, great. So we have a question from a gentleman. How much of an improvement do you expect you'll be able to make in terms of storage capacity? Right. So in terms of storage capacity, what our first product that's going to hit the market is geared at is essentially 1 kilowatt hour. And this is a great middle ground because it simplifies the design aspect of systems for installers to know that every unit can be 1 kilowatt hour. But secondly, it's generally 3 to 4 hours of storage behind every module. So the market in energy storage kind of rates things as 4-hour storage or 8-hour storage or long-term storage. And what we do with this one form factor and tying the weight to offsetting the weight of ballast is give close to a 4-hour window of storage. Now, we work with several different battery cell manufacturers. We're not tied to any specific technology. So the capacity of the storage will, of course, improve over time based on whose batteries we're adopting into our system. Dan has asked, how long will the batteries last? Will they need to be replaced more frequently than PV panels? Great question, Dan. So the question to that is specifically how long that chemistry of battery lasts initially at an STC setting, which is 23 degrees Celsius. So we are currently working with a battery partner who's tested batteries beyond the calendar life of 20 years and above 13,000 cycles. So theoretically, if we use that specific cell within our product and we regulate the temperature, we could theoretically have the full close to 10,000 to 13,000 cycle life of that battery within our SolarLEAF system. And if you account that to, let's say, a once daily full cycle, meaning 100% discharge of that capacity in one full cycle day, then that can equate to roughly 27 years of lifespan on that specific battery chemistry. Now, we may also adopt a model where we have different models of the product with different battery chemistries that last at different varying lengths. But correctly to your point, the goal of our technology is to minimize the maintenance costs. So we're designing a battery system that can mirror and actually have a 20-year design life that mirrors that of a solar panel.
Great, that's. Yeah, so I'll just answer it or ask it through the mic. I believe you've said previously you were sort of technology agnostic in terms of the type of panel. Have you seen from any of your testing that there's a particular one that works better, or has it been pretty uniform?
Yeah, so a standard solar panel either has a 60-cell architecture or 72-cell architecture. Different companies have a white backsheet versus a black backsheet. We've tested with various different solar panels, and there seems to be very minimal difference of temperature between the various options that are currently in the market. One thing that you could be referring to, Jonathan, is specifically bifacial panels. Bifacials, by general, have a glass encapsulation. They don't have a backsheet. And that's something that we are testing for as well, because it seems to be taking a greater market share in tracking systems for utility scale solar to go with bifacial type of panels. But as default, given our background in the industry, we realize that it's very important to create a system and a solution that's as universal as possible. And that means by default that our design is designed to work behind any solar module from a 60-cell. We're actually adapting it to be able to work to higher powered, higher voltage 96-cell modules as well.
Great, thanks. Well, it looks like we maybe don't have any other questions. Did you have anything else you wanted to say before you finished up, Omeed?
Yeah, sure. Just talk a little bit about kind of I was talking about how our company got to forming, and maybe I can just finish up a little bit with that. So uh, when I lived in China, I was traveling to a lot of these remote islands and was trying to design these off-grid systems that I had designed previously in my early career. And I realized that in order for solar to reach these places, storage had to be a big part of that. And in order for solar and storage to reach these places, the cost had to be reduced. And one of the biggest drivers of this cost reduction was the simplification of putting these systems together. At the end of the day, we have to get as simple as it is turning on a diesel generator or a gasoline generator to be able to compete. We're already competing well on a price per kilowatt hour point, minus the upfront cost, of course, but we have to simplify these systems. And that really began the journey of when I met Vikram, which is the co-founder of the company. And Vikram's background, used to do research at Southwest Research Institute, specifically on battery systems for electric vehicles and powertrain type of technologies. And we joined forces and we started kind of pushing the envelope on what's possible. And the only reason theoretically why this product or this form factor shouldn't exist is the temperature swings that you might experience behind a solar panel. In some climates like Austin, Texas, it can get as hot as 150 degrees Fahrenheit in the peak of the summer. And in some other climates, it can get below freezing. Both of these points of which current battery chemistries don't like to be at. Some can operate, but they degrade at a much faster rate. So really the enabling technology is the core of what we call our ZEDGE technology, which allows us to regulate this temperature of the battery, but do this completely passively. Fast forward to kind of some of the market discoveries, we realized that not only do we save a lot of pain points for these systems in remote applications and remote microgrids, but hey, actually, as more and more energy storage is being talked about and being deployed on commercial buildings to give resiliency, this is probably the best way to do it. You know, commercial rooftops are already designed to take in the weight load. Commercial PV design requires a certain amount of ballast weight to minimize or remove the need for penetration. And it was a natural progression that our battery system by default can work really well in this market. And then it turns out, well, there's a lot of utilities that are watching this space very carefully, and they've been highly interested in this because from a utility standpoint, they don't want to be in the business of figuring out how to put shipping containers next to buildings, right? They've always interfaced with customers by simply having a meter. And asking them to get into energy storage and having to manage large shipping containers and large containers was a kind of a non-starter for a lot of utilities. Whereas having a solution can now integrate completely on the rooftop. It's out of the site. It's for the most part, it doesn't stop the flow of business, and it can scale and it can be strategically placed throughout a city to really monetize on the distributed factor of having energy storage. A lot of them are very excited about our development, and as such, we're working with a lot of utilities now on deploying pilots at our stage of our company. So we're very excited of this next year, and also glad to be part of the Center for Next Generation Photovoltaics, and look forward to what lies ahead. Thanks for all for being on this this lecture series, and thank you.
Great. Thank you so much, Omeed. We really appreciate you taking the time to speak with everyone. And for those of you who are watching this later on YouTube, we have another series of videos available, and this lecture series is ongoing. So keep an eye out for our next talk. Thanks again.
Thank you, Jonathan. Have a great day.